right. Last week we left off talking about patterns in relationships. And if you remember, we plotted our heights and shoe sizes. And then we talked about the relationships or patterns that we found with those data points. So for instance, for most of us, we noticed that as your height increased, your shoe size also increased. We talked about correlation. So that would be a positive correlation as two variables increase. That's a positive correlation. So today we're going to learn about trend lines. We'll be able to draw a straight trend line to approximate the linear relationship between the plotted points of two data sets, make inferences regarding the reliability of the trend line by noting the closeness of the data points to the line, determine the equation of the trend line that approximates the linear relationship between the plotted points of two sets of data, and then we're going to use the context of the data collected to interpret y-intercept and slope. And our final I can statement has to do with kind of making future predictions about what's going to happen with sets of data in the future. So for our vocabulary, to start us off, we have a trend line. What is a trend line? Well, let's see if my pen here. It is a line that best approximates or fits the data points in the scatter plot. So we're still working with scatter plots today. Our next vocab word is linear model. Linear model, we've talked about a linear model before. It's the equation y equals m, where m is the slope, x plus b, and b is your y-intercept. A linear model is a linear function. We know that a function is something that passes the vertical line test. A linear function that is used to represent a real life situation. Represent a real life situation. So it's a model. Slope, we should know this one already as well. Last time we defined it, we listed as many different definitions as we could. It's rate of change. And we calculate it rise over run. So make any note here that's going to help you remember slope and how you find it. Slope is we use to describe slope. And the last one is the y-intercept or the initial amount if we're talking about actual data. Where are you starting? What's your initial amount? And this is where the graph is going to cross the y-axis. Should be following along in your note packets. Ooh, there's the bell. Okay, for our first example, we're going to draw some trend lines, and your answers are going to kind of vary here. But a trend line, if we flip back, it's a line that best approximates or best fits the data points in the scatter plot. So we're trying to find, with this first scatter plot, what's a line that would best represent all of those points? So obviously we can't draw a line that's going to be squiggly through each and every one of those points. So we're just going to draw a line that hits as many points as we can and keeps the data nice and close to that line. So my line is going to look something like this. It hits two of my data points. It has two above the line here and then 1 point below. So there's my first trend line. I should do one with arrows on it. Okay. Let's look at B now. Let's try and draw a trend line for B. Yours might not look exactly like mine on your homework, but they should be fairly close. With B, I kind of see 3 points right here in a straight line. So I'm going to try and connect my points with one line. There we go. Again, I'm going through 3 points, and then I have 2 below my line and 2 above. Let's pause me and work on C and D with your shoulder buddies. Ready, go. All right. Hopefully you and your shoulder buddy agreed on a line. I bet C was pretty tough for you. Is there any way that you can draw a trend line if there's no correlation at all with your data points? So I know you guys were all grossed out when I talked about does this look like it has a relationship, a pattern, or does it look like somebody sneezed on your paper? So for C, it looks like somebody just sneezed on that paper. You've got 1, 2, 3, 4, 5, 6 points, and there's no relationship at all. So you can't even try to draw a trend line because the data is not trending upwards, not trending downwards. There is no trend line. So if you wrote one, erase it and write none. Sometimes we can't approximate something without a linear relationship. For D, we should be able to draw a nice trend line there. It's going to go through, well, I can probably, let's see, hit 3 or 4 points here. There we go. Okay, so as long as your trend line looks something like that, I would be very happy. If you need to make adjustments now, go right ahead. We're going to move on to the next slide. Okay, for example 2, the table shows the number of hours students spent studying for a math test and their corresponding grade. So here we have study hours, and below that we have the grade. So study hours is actually our X variable, and grade is our Y. For part A, we're going to create a scatter plot for the data and draw an appropriate trend line. Okay, so scatter plot, first we want to start with labels. If X is my study hours, I'm going to label my X-axis study hours. If Y is grade, I'm going to label my Y-axis then grade. And we need to give this graph a title. What kind of title? Something that pertains to the table. Let's say grade and hours studied, or hours studied in grade. There's our graph title. Okay, now we need to write a scale in. We have a nice break here for grade. That's good. The lowest grade is 60, so I'm going to start at 60. And I'm going to go up by 5s. Go ahead and do this on your paper as well. And we can't have more than 100%. I'm assuming those are percentages. Okay, for study hours, ranging from anywhere from 0, it looks like, up to 5. So I'm just going to start with 0 and go up by 1 hour. And nobody studied past 5. So there we go. And now I just plot my points. 3 hours, 84. You should be doing this on your own. All right, there's my scatter plot. And now I need to draw a trend line. So I'm going to try and hit as many points as I can and try and keep the line really close to my data points. So my trend line is going to look something like like that. Okay, part B. We're done with our scatter plot and trend line. What does the y-intercept represent in the context of the data? So our y-intercept is down here at 60. What does that mean? 60 what? 0, and then the x-coordinate of that would be 0. So 0 what, 60 what? Well, 0 is the number of hours studied, and 60 would be their grade. So this is going to represent the grade a student received for 0 hours studied. So if you don't study, looks like you get a 60%, which is a D, a low D. So that's how we interpret y-intercept. For part C, what does the slope represent in the context of the data? Well, slope is rise over run, remember. So rise, that's my y, my change in y, over my change in x. Your run is your x. So change in y, that's going to be a change in grade. Change in x is going to be the change in the hours studied. So my slope is going to represent the amount the grade increases per hours of study. And we say increases because this is a positive slope. You're going up and to the right, up and to the right. Okay, so my sentence is going to be the amount the grade increases per hour of study. Running out of room since we're going up in 1 hour increments here. All right, and part D. According to the line of best fit, what grade would you expect to receive if you studied 2.5 hours? So let's go over here. Here's 2, here's 3. We're going halfway between them. If we zoom up, you're going to expect right about an 80%. We could even write a range there. Maybe it's not exactly 80, maybe it's somewhere between 75 and 80. Or maybe we want to get more specific and say 77 and, or maybe 79 and 81.
Jordan Wolcash to the office. Jordan Wolcash to the office.
About 79 to 81. Or you could even say about 80. All right, that's example 2. Let's move right along to example 3, which I believe is the last one in your notes. Yes, it is. Okay, so we have the equation y equals 15x. It represents about how many followers Randy's Donuts has on Twitter. Something we can relate to, Twitter followers. X is going to be the number of days since opening the Twitter account, and Y is going to be the number of followers. What does the y-intercept represent in the context of the data? What is our y-intercept in this equation? Y equals 15x. Well, if we're looking at the equation of a line, which is y equals mx plus b, m is your slope, b is your y-intercept. Is there a b? We could add one. We could add plus 0. So if that's where we start, what that means is it's going to be the number of followers, which is y, on day 1. Or excuse me, on day 0. So if we were to plug in 0 for x, the day, you're going to get 0 for y, or the number of followers. So this one for the first part is the number of followers on day 0. Second piece, what does the slope represent in the context of the data? Well, we know our slope is m, which is, in this case, 15. So then I can write b equals 0. What does that 15 mean? Well, it's rise over run, or the change in y over the change in x. I'm going to write that down as well. Change in y over change in x. If y is the number of followers, it's the, and it's positive. So he's gaining followers. So it's how many followers he gains per day. So for every day, how many followers he will gain. The slope represents the number, I'm going to abbreviate, of followers increased per day. So if we use this equation, approximately how many followers will Randy's Donuts have after having the Twitter account for 25 days? Well, days, that is our x variable. So we're going to take our equation, we're trying to solve for y. 15 times, how many days? Oh, 25 days. 15 times 25, that's 375 followers. So that's how we can use our equation to predict the future. We're predicting how many followers he'll have in 25 days. All right, that's all I have, I believe, for you today. So from here, you've got some time to work on your homework. If I've crossed any off, they should be on the board. Thank you.